Okay, this is question 22 from the PREP 2017 AS paper. So you have compound B and compound C. You add nitric acid to compound B and you get bubbles. You add barium chloride and there's no change. With compound C you add nitric acid and there's no change, and you add barium chloride and you get white precipitate. It says that they are ionic compounds of two different group 1 metals and their molar masses are 140. So you need to work out what the identity of B and C. So B, you add nitric acid, you get bubbles. That suggests that B is a carbonate. C, there's no reaction with nitric acid, so it's not a carbonate. But when you react it with barium chloride, you get a white precipitate. So because the barium ions react with sulfate ions to get a white precipitate, so C must be a sulfate. Common error, people think that this is some kind of silver nitrate. Well, it says it's two ionic compounds with group 1 metals, and silver is in the transition metals, not group 1. So the clue there is the barium must be a sulfate. So we've got something carbonate for B and something sulfate for C. Well, then you need to work out what they are. So we know that they are group 1 metals. So it's a group 1 metal carbonate and a group 1 metal sulfate, and they both have an MR of about 140. So if you work out the MRs of both of these, potassium carbonate is about 138.1 and sodium carbonate is 142.1, so they're around 140. So that's how we know it. Moving on to the next page. It says figure 22.1 shows the first ionization energy for elements across period 3, which is actually a little bit sneaky because, and then it says at figure 22, add a point to figure 22.1 for the first ionization energy of the element with Z equals 10. Remember, Z is the atomic number or the proton number. Well, actually these 11 to 18, if you look in periodic table, that's sodium, and they are all in period 2, but period 3, sorry, but Z equals 10, that comes from period 2, so actually that is an extra shell, one less shell, so its ionization energy will be the highest. Okay. Then it says estimate the energy required to form 1 Na plus gaseous ion from 1 Na sodium atom. Give your answer in kilojoules in standard form and two significant figures. Well, Na has the atomic number 11 and an ionization energy of 500 kilojoules per mole. So that means it takes 500 kilojoules of energy per mole to remove 1 electron from sodium to make Na+. We know in 1 mole there are 6.02 times 10 to the 23 particles, so to find out how much energy it requires to remove 1 electron from 1 atom, just divide this by this, because that's per mole, and there's that many particles per mole, and that's your answer.